Okay, picture this. You're looking up at the night sky, right? It looks completely calm, totally still. But right at this very moment, there is an abandoned human-made rocket just barreling toward the lunar surface at an absolutely unimaginable speed. I mean, this isn't some sci-fi movie plot. This is a very real, imminent, high-speed lunar collision that is literally going to leave a permanent mark on our moon. Welcome to The Explainer. We've got a truly fascinating, beautiful, and frankly wild event to unpack today.
So it really begs the ultimate question, doesn't it? What actually happens when a massive piece of our space machinery slams into the untouched lunar surface? We aren't just talking about a little bump in the night here. We are talking about a dramatic, explosive event unfolding right in the vacuum of space. And scientists, they are literally racing to understand the fallout. All right, let's lay out the facts. On August 5th, 2026, a spent SpaceX Falcon 9 upper stage is going to unintentionally crash into the moon's western limb. This is actually a leftover piece from a launch way back in January 2025 that sent commercial landers into space. For over a year, this abandoned rocket has just been drifting out there in an unstable orbit. But now, the moon's gravity has fully taken over, and it's pulling this thing down on a direct, inescapable collision course right near the Einstein and Bell craters. Okay, let's dive into this massive number right here. 5,406 miles per hour, or, about 8,700 kilometers per hour. That is roughly 7 times the speed of sound. Just try to wrap your head around that for a second. Picture something that massive, a whole rocket stage, moving that incredibly fast. The sheer scale and momentum of this impact are honestly a little difficult to even comprehend.
Now, you might be wondering, well, it's just a hollow, empty rocket stage, right? What's the big deal? And it's true, it is totally empty of fuel. But because of that intense velocity we just talked about, it is going to strike the lunar surface with the explosive kinetic equivalent of 3 tons of TNT. When the dust finally settles, it's expected to carve out a brand new crater up to 98 feet, or about 30 meters across. That is huge.
Which brings us to Section 1, a rare scientific opportunity, and what I like to call the fascinating stargazing payoff.
See, while literally no one intended for this rocket to hit the moon, this accident is actually presenting a gorgeous, real-time science experiment. I absolutely love this quote from William Joe over at the University of Texas, Austin. He says, "Watching this one gives us a rare chance to open up ejecta-plume science. The flash isn't really the story here. Basically, scientists are thrilled because they can use a known human-made object to calibrate their models. We know exactly what this rocket is made of, its exact mass, and how fast it's going. It gives researchers the largest, most detailed data to build a highly realistic simulation of lunar impacts. It's the most predictable experiment we could possibly ask for." And when that rocket hits, it is not just making a hole. It is going to kick up a massive plume of lunar dust and rubble. Because the moon's gravity is so weak and there is zero air resistance holding anything back, scientists predict this central ejecta spike could reach up to 60 miles high. Yeah, 60 miles. That is 100 kilometers of lunar regolith just blasting straight up into the dark sky. And here is where the fascinating stargazing really comes in. The impact flash itself, it's going to last less than a second, probably way too dim for us to catch. But that 60-mile-high dust plume, because the impact happens right on the sunlit western limb of the moon, that massive cloud is going to be illuminated against the pitch-black background of space. It'll be absolutely gorgeous, and it might actually remain visible to sensitive telescopes back here on Earth for tens of minutes. To make sure we capture all of this beautiful data, there is a highly coordinated timeline in place. Step 1. NASA's Lunar Reconnaissance Orbiter, or LRO, passes over the target site about a week prior to get a pristine before picture. Step 2. The rocket impacts at that blistering 5,406 miles per hour. Step 3. Earth-based telescopes track that gorgeous ejecta plume as it hangs in space. And finally, Step 4. The LRO passes back over a week later to photograph the brand new crater. It is quite literally a perfectly scheduled accidental experiment.
Moving right along to Section 2, History of Lunar Impacts. Because, well, we've actually been here before. If we take a look at this timeline, humanity's mark on the moon started all the way back in 1959. The Soviet probe Luna 1 was designed to impact, though it actually missed. Fast forward to the Apollo era from 69 to 72, and NASA was intentionally crashing lunar module ascent stages just to test their new seismic equipment. In 2010, the LCROS mission deliberately crashed into a polar crater to search for ice. And then, more recently, in 2022, a spent Chinese rocket booster accidentally struck the far side of the moon. Now, you might be thinking, doesn't the moon get hit by rocks all the time? And you'd be right. The crucial point here is understanding the difference between natural and artificial impacts. Just in 2024, a natural meteor carved out a massive 225-meter crater, blasting out 1,000 times more ejecta than our SpaceX rocket will. But artificial impacts are entirely different beasts. They involve hollow, metallic bodies that create really unique cratering dynamics. And more importantly, they introduce human-made materials, meaning potential contamination to a completely pristine lunar environment. Which brings us to Section 3, the lunar debris threat, or what happens when the dust settles forever. We really have to remember just how incredibly fragile the lunar surface is. The moon basically has no atmosphere. There's no wind, no rain, literally no weather to wash away our mistakes. Any mark we leave, whether it's a rover track, a human footprint, or a 30-meter crater from a crashed rocket, it is going to remain there for thousands, perhaps even millions of years. And this brilliantly illustrates the exact concerns being raised by the European Space Agency right now. The risks of these high-velocity impacts go way, way beyond just digging a hole in the dirt. The ejecta could easily contaminate the protected polar regions where we are actively searching for pristine ice. The flying debris poses a very real danger to our current lunar orbiters. All that dust can fundamentally alter the moon's natural exosphere. Plus, any surface assets we put up there, like future habitats or rovers, could suffer serious seismic or particulate damage.
Seriously, just look at these calculations from the ESA. Because lunar gravity is so low, impact shrapnel travels terrifyingly far. A piece of ejecta with enough kinetic energy to cause an uncontrollable spacesuit leak could travel over 5 kilometers. 5! Even worse, shrapnel with enough force to cause a fatal terrestrial casualty can be thrown up to 12 kilometers away. That's wild. If we're going to build relatable, working bases on the moon for humans, random rockets crashing from the sky is a massive, massive hazard.
So, how do we fix this? Section 4, protecting lunar heritage sites and preserving Apollo. See, this risk isn't just about protecting future astronauts. It's about protecting our past. We have invaluable historical artifacts up there, particularly the Apollo landing sites. I mean, they represent humanity's very first steps on another world. To preserve this extraterrestrial heritage, NASA has actually drawn up guidelines recommending strict exclusion zones. The idea is to protect those iconic footprints, the rover tracks, and the historic landers from literally being sandblasted by impact dust. Right now, NASA recommends a 2-kilometer safe radius around heritage landers and a 0.5-kilometer radius around past impact sites. Now, what's really interesting about this slide is the math behind that preservation. It's like a giant puzzle. As you start adding in all these protected heritage sites, like the 6 Apollo locations, the 23 global landers, and eventually all 90 historic impact sites, plus the protected polar regions, the actual safe zones for intentionally crashing old satellites begin to shrink dramatically. We are slowly but surely running out of safe places to throw our space junk. Thankfully, this upcoming SpaceX crash is happening safely away from any Apollo sites, so our heritage is safe for now. But it is a huge wake-up call for us. The international community desperately needs a cohesive legal and regulatory framework. Right now, experts are proposing standardized notices to lunar operators to flag any dust-generating activities. There are also growing urgent calls for a 4th UN conference on outer space, so diplomats and scientists can finally figure out how to share the moon without ruining it for everyone. So I want to leave you with this final thought as we prepare for this incredibly gorgeous, fascinating cosmic event in August 2026. As humanity expands its reach and permanently reshapes a celestial body, who actually gets to decide the fate of the moon's environment? How do we balance the thrilling, beautiful awe of space exploration with our profound responsibility to preserve the lunar landscape? Definitely something to think about the next time you look up at the night sky. Thanks so much for joining me on this explainer, and as always, keep looking up.